Hello everyone. So in this video we are going to solve a question of LeetCode, that is find the duplicate number. This is 287th question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given an array of integer nums containing n plus 1 integers where each integer is in the range 1, n inclusive. There is only one repeated number in nums. Return this repeated number. So basically we need to return the number which is repeated in the array. You must solve the problem without modifying the array nums and use only constant extra space. So basically in this question we have given an array and we need to output the number which is repeated in the given array. So there are multiple approaches to solve this question. So we will be discussing three approaches here. So let's take first approach. In the first approach, what we can do is we can just sort the array. So in the first approach we will sort the array. Let's say we have taken this array, so we will sort this array. So let me just write the approach here. So let's say we have this array. So if we have this array, so after sorting we will get 1 2 2 3 and 4. So after sorting we will get something like this. Then we will take two pointer, first one, not two pointer, we will just directly iterate through the given array and we will check whether the ith element is equal to I plus 1th element or not. So if they are equal, then we will return that ith element. Like in the first case, ith element is not equal to I plus 1th element, so we will just increment I. Now in the second iteration, I is equal to I plus 1th element, so ith element is equal to I plus 1th element, so we will be returning ith element from here. So this is 2. So this is a sorting algorithm which we can use in this question, but as mentioned here, we cannot modify the array, but in the sorting it will internally modify the array, so this won't work here. And the time complexity of sorting is big O of n log of n, and space complexity is big O of log of n in C++, and if you do in Python, so this might go up to big O of n. So this won't work here because it will take a lot of time. You can optimize this with some other approaches and you can also reduce the space. So let's see some other approach. So in the second approach we are discussing is hashing. So hashing is basically an approach in which we store the key and value. So let's say we are storing all the numbers as a key and we will just keep the frequency as a count. So let's say we have 1, so for 1 we have frequency as 1, for 3 also we have frequency as 1, then for 4 we have frequency as 1, and for 2 we have frequency as 2, or we can say 2 has a count of 2. So definitely if the count is greater than 1, then that element must be repeating in the array, so we will be returning that element, or we can say that key from the fetch function. So the time complexity of this approach is big O of n. We have just optimized the time complexity from the sorting function, but the space complexity is increased. So this function, or we can say this approach, will take around big O of n time complexity. So as it is mentioned here, use only constant extra space. So this approach will also not work here. So let's discuss another approach. So another approach is linked list cycle detection. So linked list cycle detection method, or we can say it is the detection, or we can say this is the Flyod's algorithm. So let's discuss this algorithm. So let me draw something here. Let's draw something here, I guess. Yeah, so let's draw the first example. So in the first example, we have 1, 3, 4, and 2, 2. So let's take the first one. So 1 will be here. Now let's connect 1 to 1th index. So at 1th index, we have 3. Let's connect it with 3. Now let's connect 3 to 3th element. So at 3th index, we have 2. So let's connect it with 2. Now let's connect 2 to 2th index. So at 2th index we have 4. So let's connect it with 4. Now let's connect 4 to 4th index. So at 4th index we have 2. So let's connect it with 2. Alright. So now we have completed the iteration. Now let's take two pointers here. First one is the slow pointer and second one is the fast pointer. So what we do, we just move slow pointer by 1 and fast pointer by 2. So let's check here. Initially slow and fast pointer are at 0th index, or we can say they are at 1. So let's move slow by 1 and fast by 2. So slow will come here and fast will come here. Alright. Yeah, so slow will come here and fast will come here. Now in the next iteration let's move slow by 1. So slow will come here and this fast will move by 2 steps, so it will again come here. So now fast and slow are both of them are at same position. So whenever the fast and slow pointer are at same position, what we do? We just update the fast pointer to 0th index. So now fast will come to 0th index. So fast will come here. So now what we do? When fast comes to the 0th index, so after this we just move fast and slow with same speed, that is both will be updating by 1. So let's update them by 1. So fast will come here and slow will come here. In the next iteration fast will move on to here and slow will move on to here. Now again fast and slow are at same positions. After moving the slow and fast pointer by 1, they both are at same position. So what we will do, we will be returning this element from here. We will be returning 2 from here, as 2 is definitely repeated in the given array, or we can say in the given vector. So we will be returning true from here. I hope the approach is clear to you. So the time complexity of this approach is big O of n, because we are iterating through all the n elements of the array, and space complexity, let me write time complexity here, and space complexity of this approach is big O of 1, because we are using constant space um, for storing two pointers here. Alright, so not pointers, they are basically two elements here. So this is the approach. So let's quickly code it up. I hope the approach is clear to you. So let's take two pointers here. Let's take slow is equal to nums of 0 and int fast is equal to nums of 0. Now let's run a loop. Let's run a do while loop. So in the do while loop, what we do, we will just update slow to nums of slow and fast to nums of fast, because we are moving by 2 steps here. Now run this until while slow is does not equal to fast. Now update fast to nums of 0. Yeah. Now let's run a while loop until slow does not equal to fast. And in this while loop, let's update both by one step, like increment both by one step. So slow will be equal to nums of slow and fast will be equal to nums of fast. At the end, just return slow from here. Slow from here. I hope it should work fine. Let's just run it. Yeah, it's working fine. Let's just submit it. Yeah, it's working fine. Now let's calculate the time and space complexity. So the time complexity of this approach is big O of n. This is a linear time complexity, and space complexity is big O of 1. That is a constant space complexity, or we can say constant space. So I hope the approach is clear to you and the solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.